Okay. So there's several ways to go about this. They want the derivative just at 9. So what I could do is do the whole function using just x and a and then plug in when I'm all done. Or I could plug it in now. So here's what I could do. Don't write this down yet. I have the limit as x goes to a, square root of x minus 6 minus square root of a minus 6 all over x minus a. You follow that? Or I could say limit as x goes to 9, square root of x minus 6 minus square root of, go ahead and plug it in, 9 minus 6 is 3, all over x minus 9. Because your a, it's saying you're going to that point. That is your a. Do you see how that is saying the same thing? One I'm plugging in now, one I'm plugging in later. Now, to be honest with you, this is probably easier to do. However, this may have more uses. Because if I ask you in the next slide to find the derivative at 2, you're going to have to do, if you use this, you're going to have to do the whole thing all over again. Whereas if you use this, all you do is plug it in the end. Do you understand what I'm saying? I tend to use the generic form, so that way if I ask a bunch of questions, I can just answer them all right away. Whereas if I plugged it in now, I have to do it for every problem. So let's go ahead and do the generic just to get some practice. Now you can write it down. Okay, how do I solve this? Can't just plug it in, right? Because if I plug it in, I'm going to get 0 on the bottom. Times by the conjugate. X minus 6 plus square root of a minus 6 all over square root of x minus 6 plus square root of a minus 6. Okay, so I have limit x goes to a. Now up here, these two are going to cancel and give me x minus 6. Then I'm going to get plus the square root minus the square root. I'm not going to write those. We should be able to see that those inside terms are always going to cancel, correct? But the last two, be careful. When I multiply these two, it's going to be minus all of that. Now remember, when you do the conjugate, I didn't do the conjugate at the bottom, so I should always leave it alone. Remember that? So the limit, x goes to a. So up top I'm going to have x minus 6 minus a plus 6. So what happens? 6 is cancel, and actually x minus a, right? So I really have the limit x goes to a 1 over square root of x minus 6 plus the square root of a minus 6. Everyone follow that? Your x minus a, x minus a. Now here's where a lot of people get confused if you're plugging in a or x. Think about it. If I had a limit as x goes to 2, you're going to plug in 2, aren't you? Yes? If I have a limit as x goes to a, I'm going to plug in a. So I end up getting 1 over 2 square root of a minus 6. Yeah? So I just found f prime of a. Now, I like to write it as f prime of x. Does it really matter? No, it's just switching a variable, right? Because all of our, so if I asked you for a function, you would give me this. But this leads us to my answer because I want to know f prime of 9, correct? That's what they asked me to begin with. So when I plug it in, I have 1 over 2 square root of 3. What's that?
It's at -1.
That's at 9, I believe. So x equals 9. You can't read your own writing, can you?
No, I was looking at the problem before.
But of course I'm not going to leave it like this, correct? Get that square root out of the bottom. So I have square root of 3 over what? 6. Now, notice I didn't get the square root out of the bottom here because it's a function. We're going to get some really, really gross, nasty functions in this chapter. We don't really bother cleaning those square roots up.
Gross, nasty.
And there they get huge. And they do get gross. But this is my answer. This is the slope at 9. Right there. You get the idea?